How many different ways can 3 girls and 4 boys be arranged in a row if no 2 people of the same gender may sit together? So I've got this drawn out as boy, girl, boy, girl, boy, girl. So I've got alternating genders. Okay. How many boys are eligible to sit in the space furthest to the left? Well, we haven't used up any boys yet, so 4. How many girls are eligible? Again, we haven't used any up, so there's 3. How many boys? We've used 1 up. 3. Girls, we've used 1 up. 2. Boys, we've used up 2. Girls 1. I just realized we're short 1 boy. Mathematically, it's a 1. It's not going to matter, but let's dump that in there. Okay, so we get boy and girl and boy and girl connected by and or multiply. You'll notice if we take all the boys, we have 4 factorial. If we take all the girls, we have 3 factorial, 4 factorial, multiplied by 3 factorial gives us 144. Okay, and last question. In how many ways can all of the letters of the word oranges be arranged if there are no restrictions? Okay, so no restrictions. How many ways can we use all of the letters in the word oranges? Okay, so let's start by counting the oranges. O-R-A-N-G-E-S. So again, we want to be really careful when we're counting those. I see 7 letters. Okay, we want to use up all of them. So we can go 7 P7, that's our new formula for today. We could go 7 factorial over 7 minus 7 factorial. Or we could go 7 times 6 times 5, 7 factorial. Okay, so for letter A, get 5,040. Okay, for letter B, we want to deal with the restrictions first. The question says the first letter must be an N. So we have 1, 2, 3, 4, 5, 6, 7. There's only 1 N in the word oranges. It needs to go first. Okay. Otherwise, there's no other restrictions. We have 6 letters left. Again, we want arrangements. It's a permutation. Order's important. If we use it second, we can't use it third. If we use it first, it was an N. It can't be in the second position. When we work this out, 6 factorial. Okay, as you work 6 factorial out on your calculator, just be aware, as we become more restricted from A to B, and then as we work through into letter C, as we become more restricted, the number of permutations decreases. Letter C I'll do above. The vowels must be together in the order O, A, and E. So I'm going to treat the vowels in the order O, A, and E as one arrangement. Okay, I want to think about this as if it's a Scrabble tile. I have O, A, and E all on the same Scrabble tile. That still leaves me with R, N, G, and S. 1, 2, 3, 4, 5, 6, 7 letters total. I still have 4 to go. Now, because it has to be in the order O, A, and E, I know there's only one way to put that particular Scrabble tile. If we look at these as a group, we have 5 Scrabble tiles to organize. One happens to have 3 letters, but we have 5 tiles to organize. Okay, so the O, A, and E group could be first, it could be last, we're not sure. Basically, we have 1, 2, 3, 4, 5. 5 things, 4, 3, 2, and 1, or 5 factorial. 5 factorial being 120. Again, as we went from A, no restrictions, to B, more restrictive, there's a particular letter first, to C, most restrictive, O, A, and E needs to be together, we decreased the number of arrangements.